Let's talk about engineers and how they seem to think a little bit differently from the rest of us, and how we can learn from that mindset for problem solving and for the metaphorical and literal treasure hunting that we go on in our lives. As many of you know, this channel this is based upon this theme of treasure hunting and alternate reality gaming, but it's not just about that. It is for designers and hunters and participants and so forth, but it's really about the mindsets and the skill sets and the observational skills and the design thinking principles that can be a great benefit and blessing to us in our families, our workplaces, our lives, and other places. And so I am not an engineer by training. I have a number of degrees in different areas, and I am fascinated by studying how people from different fields look at things. So, for example, how does a biologist look at answering a question compared to a chemist? And maybe it's the exact same question, but their training and the way that they've been equipped to think like a biologist or a chemist or a philosopher or a computer scientist or, yes, an engineer leads them to look at it a little bit differently. They ask different questions. They have a different body of knowledge and vocabulary for going about those topics, those themes. So let's talk a little bit about engineers. And again, some of you maybe who are listening to this, maybe you are an engineer and you might challenge some of the ways I'm talking about this. I'd love to get your corrections and your suggestions in the comments. But I think I have a general sense, as I've gotten to know engineers, I've worked with engineers over the years, I noticed that they seem to have some things, some patterns of thinking that help them solve problems and come up with novel solutions that oftentimes the rest of us miss. So maybe we don't have to miss them. Maybe we can learn from their skills a little bit, even if we don't have the formal training of an engineer. The first one that I notice is they seem to be really good at taking a complex problem and breaking it up into simple parts. What an amazing, simple gift. And it's fascinating how many times we just fail to do that. We have this complex problem. We just think about the big problem and we sort of obsess over the big problem rather than figuring out, okay, is there a way that I can break this into smaller, discrete problems? And then by solving the smaller problems, that will lead up to that end result where now I'm ready to figure out the big one. Now, sometimes these are interrelated, lots of connections, but it helps you from getting overwhelmed. It allows you to break down a problem into a series of steps and look at it with greater attention and greater detail. The second one that may be related is they seem to question the design behind what they see. And so when I look at a table, I just see a table and it's functional, but a designer might actually pay attention to that table and consider the design principles that are present. An engineer might think from a design perspective and think about why is it sturdy, and I wonder how they went about this, and what kinds of what kind of braces did they use, and it might ask different questions to really understand how it's constructed, and getting behind what you see, getting under the hood, trying to understand how it actually works, gives you much greater appreciation and insight. I know that years ago, when I first graduated from college, I didn't have a computer science background. I was a teacher in a middle school and a high school, teaching mostly social studies, and I taught religious studies. I was in a Christian school. And I took some computer science classes and some computer information systems classes, and for fun in the evenings. And I got to, build computer networks and build computers from scratch and learn some different programming languages and other things like that. And one of the things that I learned is that after doing that for a while, when I would work in a very simple application, something like Microsoft Excel or Microsoft Word, that I began to think about it through the lens of the designer. Thought about, and I began to be able to find where the features were more easily, because I was trying to put myself in the mind of the designer of that software. And I had enough background knowledge about how computers worked and how applications were written that I could ask those questions and see them. That's a great gift for us when we're trying to do truth seeking and problem solving and metaphorical and literal treasure hunting. The third one is that they tend to look for system flaws They tend to look not only for how it was built and how it worked, but how it was maybe under optimized. And so they look for weak points or gaps or errors or things that are missing. And that also is a great gift when we're going about problem solving and literal and metaphorical treasure hunting. If we're willing to actually look at it and say, okay, we have some solutions here, we have some possibilities here, but what's missing? What have people not done in the past? Or what are ways that this could be optimized beyond or beyond what I've thought of? Or what are those gaps or those errors or those mistakes? And then the fourth one is, I'm sure it's not true for all engineers, but this is maybe even a bias that I have, is they seem to tend to prioritize function over appearance. Does it work? Make it functional. And it doesn't mean that engineers can't be good at making something beautiful and elegant in the process as well, but this attention to functionality, making something really work, as opposed to getting overly obsessed with the surface level beauty of it, starting with getting something that actually functions, actually works, actually helps solve the problem. And oftentimes, I think we can get in our mind that we have this end result and it has to look perfect and beautiful, but we don't think in terms of kind of a first draft that will work, a prototype that will demonstrate proof of concept, and then we can kind of we can work from there, which leads me to the last one. It seems as if engineers often think in terms of iterations. So they don't just think in terms of a single solution, but a tentative solution to the problem that they test out and they gain insights from it, and then they iterate and they try additional improvements. If that solution seemed to work somewhat and has promise, continue to build on it and iterate, so that you take something that maybe wasn't very elegant or beautiful, but it was functional, and you continue to refine it to the point where it's really getting some things done. Now think about these 5 principles and how we might be able to use them in any aspect of our work and our life for problem solving, for trying to discover those literal and metaphorical treasure hunts. I think there's a great treasure in learning from the mindset of an engineer.